And welcome back to Python lessons on Codecademy. So today we're starting a new topic which is on bitwise operators. So this is going to be more of an introduction with 5 lessons which will teach us a bit but not that much. So let's get started. So this is just giving us examples of what we're going to learn in this topic. Let's just read what Codecademy has to say to us. Welcome to an introduction level explanation of bitwise operations in Python. Bitwise operations might seem a little esoteric and tricky at first, but you'll get the hang of them pretty quickly. Bitwise operations are operations that directly manipulate bits. In all computers, numbers are represented with bits, a series of zeros and ones. In fact, pretty much everything in a computer is represented by bits. This course will introduce you to the basic bitwise operations and then show you what you can do with them. Bitwise operators often tend to puzzle and mystify new programmers, which it kind of does to me. So don't worry if it confuses you as well. So don't worry if you're a little bit confused at first. To be honest, you aren't really going to see bitwise operators in everyday program. However, they do pop up from time to time, and when they do, you should have a general idea of what is going on. In the editor are 6 basic bitwise operations. Click Save and submit code and see what the console prints out. All of them will be explained in due time. So I won't bother explaining them now, because there will be videos on each one of them and how they work. So it manipulates bits. That's basically what we need to know for now. Let's move on. Lesson 1.0. Lesson 2. In binary. The base 2 number system. When we count, we usually do it in base 10. That means that each place in a number can hold one of 10 values, 0 to 9. In binary, we count in base 2, where each place can hold one of 2 values, 0 or 1. The counting pattern is the same as in base 10, except when you carry over into a new column, you have to carry over every time a place goes higher than 1, as opposed to higher than 9 in base 2. We use 0 and 1 because we use true and false or off or on in capacitors. For example, the numbers 1 and 0 are the same in base 10 and base 2. But in base 2, once you get to the number 2, you have to carry over the 1, resulting in the representation 110, or actually 10, because we're in binary. It's not going to be 10, it's going to be 2. Adding 1 again results in 11 or 3, and adding 1 again results in 100 or 4. Contrary to counting in base 10, where each decimal place represents a power of 10, each place in binary represents a power of 2, or a bit. The rightmost bit is the ones bit, 2 to the 0 to the 0 power. The next bit is 2's bit, 2 to the first, then 4, 8, 16, 32, and so on. The binary number 1010 is 10 in base 2 because the 8's bit and the 2's bit are on, as we have a visual representation of it there. In Python, you can write numbers in binary format by starting the number with 0b, so that just means binary. When doing so, the numbers can be operated on like any other number. Take a look at the examples in the editor. Really try to understand this pattern before moving on. Click Save and submit when you're ready to continue. So when we have a 1 in the 1's column, we have 1. Then we have a 1 in the 2's column, we have 0 in the 1's column, so we have 2. We have 1 in the 2's column, 1 in the 1's column, so we have 3. And it goes like that, so on. You can also add bits like that, and if you add 1 to 3, you get 4, as you can see there, and if you times 3 by 3, you get 9. So let's just move on, or you can pause the video here if you wanted to see what more clearly. So I can count to 12, or 1100, and in this case 1100. Alright, time to practice counting in binary. To make sure you've got the hang of it, fill out the rest of the numbers all the way up to 12. Please do not use the str method or any other outside functions. Here are a few numbers that will be good to know going forward. So just knowing the powers can be helpful. You may recognize these numbers. Do you have a 32 or 64-bit system? Does your computer have 256 gigabytes hard drive? Computers think in binary. I know that they sometimes use that to cheat with memory, such as instead of using 1024 of a value, such as example, if you use 1024 kilobytes, you get 1 megabyte, but sometimes they might say 1000 kilobytes is 1 megabyte, but it's actually not for a computer, so you lose out some memory. I know that I have a 64 gigabyte memory stick, but it's not 64 gigabytes, it's some more like 60 or 62. So that's how some people cheat on to make more money. I don't know why. You can ask the people who make the memory sticks, I guess. So we need to fill out the rest of the numbers with their corresponding binary values up to 12 in the editor to the right using the binary format. So 4 is, well, we can actually just copy this everywhere because that's the simplest thing to do, so that I don't have to type it out each time. And then we have 4 is going to be 100, 101, 110, 111, 1000, 1001, 1010, 1011, and 1100. So that's 12. So it's pretty much just counting each column and what each column represents. So the first column is 1s, second column is 2s, third column is 4s, fourth column is 8s. So here you have 1 8 and 1 4. So oops, oh my bad, I need to go back now. And will I need to, no, I don't need to redo that. Good. So you have 8 plus 4 is 12, so that's going to print out 12. And this is going to be 8 plus 2 is 10, plus 1 is 11, and so on. So let's move on. Excellent. The biggest hurdle you have to jump over in order to understand bitwise operators is learning how to count in base 2. Hopefully the lesson should be easier for you from here on out. So that is literally what you need to do for bitwise operators. You just need to learn how to count in base 2, which is pretty easy if you can use it logically, or use base 10 as an example, and then it gets easy if you can compare those two. There are Python functions that can aid you with bitwise operations. In order to print a number in its binary representation, you can use the bin function. Bin takes an integer as input and returns the binary representation of that integer in a string. Keep in mind that after using the bin function, you can no longer operate on the value like a number. You can also represent numbers in base 8 and base 16 using the oct and hex functions, so octal and hexadecimal. We won't be dealing with those here though. We've provided an example of the bin function in the editor. Go ahead and print and bin to print out the binary representations of the numbers 2 through 5, each on its own line. So let's just copy and paste that 5 times and just change that number. And I didn't mean to do 23. That was just a mistake. 4 and 5. So yeah, that's basically it. It's pretty simple. It converts an integer into a binary number. So let's move on. Int second parameter. So going the other way basically. Python has an int function that you've seen a bit of already. It can turn non-integer input into an integer like this. So you can turn a string, a float, a double into an integer, or from what we know for now. What you might not know is that the int function actually has an optional second parameter, which is saying which base the number is in. When given a string containing a number and the base that the number is in, the function will return the value of that number converted to base 10. In the console are several different ways that you can use the int function's second parameter. On line 7, use int to print the base 10 equivalent of the binary number that. I think that's 191. well, it's definitely an odd number, because you know if a number is an odd number if it has a 1 in its last position, because it can't be an odd number if it doesn't have a 1 in its last position. So let's do this. So we need to get int that and base 2, and this actually needs to be a string, otherwise it doesn't work. I don't know why it doesn't work, it just doesn't. Oh, it's actually 201, not 191. My bad. Okay, so thanks for watching this video. If you have any questions or comments, please do comment in the comment section down below. If you like the video, please click the like button, as well as the subscribe button, and share the video. If you didn't like the video, please click the dislike button and give me a comment of why you didn't like the video so that I can improve for next time. So until that next time, thanks for watching and goodbye.